Hello, everybody. Welcome back to Electric Vision Entertainment, where we're all about tech, thoughts, and thick hair. I am your host, Aleia Knight. Welcome back to the show. If it's your first time here, welcome. We do tech things here. We talk about science and technology. We code, we build robots, we play with circuits. We do all sorts of things here on the show. And it's only going to get better, so make sure to go ahead and follow us on Twitch. You're already here, so you should already know what to follow us. We'll do this every Saturday at the same time, same place. We might do different things on the show. Like I said, last week we worked with some LEDs, building a simple circuit for like a Simon game. This week we might do soldering. Next week we might do, who knows, we'll see. We're just going to iterate and keep it going. If you're not new, welcome back. Glad to see you again. We are going to do some more fun stuff on the show today. Sometimes in the past few weeks, we've done some more tutorial-based type things, whereas this is what an Arduino is. This is what electronic parts are. This is a little bit of how to set up and read circuitry or schematics from their just basic schematic drawing. Other times, like in the past 2 weeks, we've been more focused on trying to build out full circuits. And this time on the show, we're not going to too much focus on building out a full project. This is more a little tutorial in a sense. We want to, over time, build more complex circuits, right? As we build these robots, sometimes we might just use a kit. I plan, hopefully, in the next few weeks for us to get a robot kit, and we're just going to build that. And as a result, with those type of robots, usually we don't have to do as much soldering and circuitry work. The circuit's already built for us. All we have to do is just, connect the wiring, get all the power up and running, and then program it. So a lot of that is more programming based and building the body. But there may be times, like for instance, I was mentioning on the show, we were talking about Arduinos, like, this Uno R3. And, we can buy this Arduino or this circuit as is, but there's also ways for us to build it from scratch. So that's something we probably are going to get into the next week or two, is rather than buying these all the time, how can we build one ourselves? Even if it's not a full functioning Arduino or full functioning circuit board, even just a small circuit, say I want to build like a circuit that does like an alarm system, I think I've mentioned before, where I could set up a infrared sensor, ultrasonic sensor, and if something passes in front of it, it might make a sound, it might turn an LED on. For something like that that's not overly complex, we might not need a whole circuit board. We just need, the chip, power source, a ground source, and enough wiring to connect all of the sensors together to be programmed. And that's it. We don't need a bajillion other functionality for it. In those cases, we can make our own circuit. So like using something like this, and I'll pull it up when I switch over. I'll go more in depth into like a board like that. I mentioned it a little last time, but we can create those from scratch ourselves. And that's how a lot of people do more of their more advanced or more custom robots that they make. Rather than using a kit, they decide, I'm just going to draw up a circuit of what I need. And like I said before, you can always send out that circuit design to like a PCB, a circuit board company, and have them print it out all fancy on the board and do it that way. In which case you still have to put the components on. You still have to like mount them on, and that's a whole different thing. We'll talk about that a little bit in a few minutes. But you could also just say, well, I don't want to send it out. I want to test to make sure it works at home first. Or maybe I just don't need it to be fancy. I just want it to work. Sometimes you just need it to work. It doesn't have to be fancy, especially when you're prototyping, which is why these type boards here are called Protoboards, because it's for prototyping. And once you're done with that and your circuit works, then you can say, okay, I'm going to send it out, get it more clean and fancy, surface mount the parts, all sorts of things. So what we are going to do today is I'm going to talk about soldering. basically, so I want to get, it's one of those foundational skills. When you go into electronics, robotics, you need to know how to solder. Even if not, you know, it can come in handy with just say, I'm sure we've all had those experiences, maybe not so much now because we all have wireless headphones, but in the past, we've all had wired headphones and they break easily. They just, the one side will go out and then like a week later, they're both out. And it's usually just where the cabling just barely came loose, so it isn't making a connection. If you know how to solder, you can just take off the wiring, solder those two pieces together, and then it works again. So basically, what soldering is, you know, I think of it from two ways. One is glue, is really what it is. You're gluing pieces together, but instead of using something that's based off like rubber or plastic, we're doing it with metal. The upside is conductivity. You know, you can still put a piece to a board and have it still work and have the electricity and current run through it because we're putting metal to metal. The downside, well, not even the downside, it's a bit more intense than glue because you're not just getting the glue and putting it on the board and doing things like that. You're actually, you have to melt the metal. It's like, I like to think of it as welding, you know, like just really big, like torch welding, or even like blacksmithing where you have to melt the metal and form it perfectly. It's like that, but in an extremely smaller scale because we don't have the like giant machines and systems and pipage and saws or whatever. We have small little, you know, electrical components here. So it's a lot more precise. I like to do it. We're going to get into it. I'm going to share my screen, probably talk a little bit more about what it is before we actually do it. But I'm going to go ahead and share my screen so I can show you some of the basic tools that we're going to need in order to get started into doing this. So here's my workstation. I tried to have it a little cleaner for you guys so we can, there's stuff everywhere still, but we need space to solder. So the first important thing, of course, is your soldering iron. This is my soldering iron. These helping hands. There's cables everywhere. So let's slide these boys out the way. So this is my soldering iron. This is a station. It's not as tight as I want it to be, but it's fine. It'll work for our purposes today. You can always get like a higher quality one where the setup is more, looks more like a power supply. It has a lot more functionality, but for just our basic purposes, I just got a basic soldering iron. So this is what they look like. It's like a pen, but instead of write with it, you melt things with it. So this tip here, extremely hot. I think mine goes to 450 degrees Celsius. So that is a lot. It is, I think if I turn this all the way up, the tip turns red. That's how hot it gets. It's very dangerous, which is why, you know, talking about it in the past, I show you to do it and want to make sure that I have everything I need. Usually I'll have gloves too, not always. I'm usually pretty careful. So you have that. Then you also have your sponge. I'm just using this regular sponge and it's wet. That's because you need to clean it every time you solder something. You just take like excess off. There are two types of sponges. Usually I don't use these types. These are fine. But there's another one. It's called a brass sponge. I'm sure we've all used those like pot cleaners that are just like brass or like copper wire. You had like a Brillo pad or some such. It's basically like that, only usually it's like gold instead of like a silverish color, grayish color. And you do the same thing where you rub it against it, only it's using more, you don't wet it, you use more friction in order to get it off. I prefer that than the sponge, partially because, of course, this is wet, so it's going to cool down the iron every time I use it. So I have to wait a little longer for it to. So slide that out the way. So what else we need is these wire cutters, and that's because when we solder the piece to the board, we don't want the excess of the component sticking out, so we cut it off with some wire cutters. Then you need solder, of course. There's different types of solder. wire, I just have the basic one that came with my kit. So turn this around so you can see it a little better. There you go. Invested in this camera is so much better. We made an investment, guys, in a better camera. We're still adjusting to it, but it's so much better than the other one. So you'll see that over here on the side, there's two types of solder that you'll predominantly find. The PB, of course, is lead. There's lead-based solder and non-leaded solder. And that's just because, you know, lead is toxic to humans. It'll give you a bit of a better connection among some other things, but of course you're melting this metal, so you're getting like fumes up in the air. So a lot of people prefer to use non-leaded, but it still probably has a little bit in there. This one is like 40% lead, so it's not non-leaded. So it'll be a little, I don't have to heat up as hot. I usually stick to 400 degrees when I do this. What else do we need? So, what other I have parts everywhere still. Tweezers, of course, just for like moving components. You don't have to use them. Then you have desoldering wick, which is my preferred way to take it off. So there'll be times, of course, where no one's perfect. You might put too much solder. You may solder the wrong part and later decide like, oh, I don't need to. So you need to take it off. And, you know, there's unbinding agents for different glues, right? This is basically the equivalent of that, where I'll show it in a demonstration how it's used, but basically you get this wick on the side, and it's like a braided, it's a little tiny, but it's just basically braided wick, and you hold it against the solder, and it breaks it down, so it like sucks it up. There's also other ways to do it, which is like, look at my soldering kit because I don't use this. But I'll show what it is. I just never use it personally because it's just annoying. I don't like it, but you can use it. If you're doing like really heavy work and you're putting a lot of solder, say you're putting like an LED and there's a bunch of connections, you put too much, you can use this desoldering tool in order to take it off. So you would like push the pump, hold this side against whatever component you just put on, melt it just a little bit. So you gotta turn the heat down, but melt the metal just a little bit, and then you push the button and it like sucks it out. For me, it's just inconvenient, so I never use it. But in case, it's an option. And then of course we need a board. So we're not gonna do, like I said, a whole circuit today with this, partially because of the type of board this is. I'd have to do a little practice to get it. And like I was showing you before, where there's like chunks of 3 on here, and then along the sides, there's the 3, but at the top, they're all connected. So like at the top and the bottom, whereas in a solid row, is where I would usually put power and ground. And then that way, say I can just connect power on one side here. Where's my tweezers? Over here. I could put like a connection to power. And then over here, I could put a connection to ground. And then I have this whole line will become power and this whole line will become ground because all of these connectors are connected metal wise. Whereas here, they're only in sets of 3. On the other side, you'll see, there we go. These are all separate. So the copper that's around them, they're all individual. And therefore, anything that's connected on this side isn't reacting with anything else. But because of it, the solder is going to go through. And what type of soldering we're going to do today is through-hole soldering. As you see, like, these are holes. These can go through them. So we're going to do through-hole. It's probably the most basic to do when you're getting started. It's the best way for prototyping. I said it's the quickest, the easiest, you just can get it done. The alternative, which is a lot more complex, I don't think we're probably going to do it on the show, we'll see. Because I haven't done too much of it myself. I've done a bit of it, but it's so intricate that I'm not sure 100% if we'll get into that. I'm trying to find something heavy to hold on my soldering iron because it wants to flip over. So, I have enough. Make this work. The alternative is, let's see if I can find something. Say this Arduino, right? So if you look at this Arduino, you see all of these pieces on here. None of them are through hole. And you kind of on the sides here. So you see like up here, you have some holes along the sides. Down there, you also have some holes along the sides. Technically, they go through to the other side. So if you want to add components, you could, and it would be more through hole. But when you look at how the components are actually set up on here, around this circuit, this crystal here, these other circuits, these integrated circuits, even like along here, these resistors and these LEDs, those are not through hole. They are just sitting on top on the surface. These are called surface mounted soldering. This is what 99% of all industry electronics use at this point is surface mount. If you want to get into like professional developing of like robotics, technology, electronics, this is probably your best bet of what to learn is surface mount. If you work at a big tech company and you work in electronics, it's almost crucial for you to know how to surface mount. And a lot of the certifications for soldering, forget the names of them, but they're surface mount, not through hole mounting. Just because as technology evolves, we want to have smaller and smaller devices that can still perform the same. So there are resistors on here that are the same as like these. They can be the exact same resistors, the same amount of ohms and everything. But because we want them smaller, they just shrunk it down to be like this, to where they're usually like little boxes. I don't think I have any because I'm not gonna do that. But they're extremely small. I know a couple times when I was being tested to work at Intel, I had to have a test where I had to sit in the lab and had to solder. And I was like, yeah, I know the through hole solder and the surface mount. And then I say those pieces were tiny, like I had to use these tweezers that were like, let's see if I can do it. They were like this big. As blurry as I want to not focus. But it was literally like the pieces were this tiny. And I was like, I don't know how you expect me to do this. It got done. I'm not sure. It was crazy. So I think that's the basics. Sometimes I use tape when I'm putting things on. So for instance, let me grab a part. I said today we're not building like any actual circuits or anything. I'm just gonna solder things for like 30 minutes and we're just gonna talk about it. If you have like questions and things like that, then yeah, if you have questions or anything or like want to have anything like that, feel free to ask in the chat. Whether soldering, such a funny word, soldering related or not, feel free to ask. I'll do my best to answer. But for instance, let's say, I'm trying to find a loose resistor everywhere. So say I want to put this resistor on, right? This resistor. I will put it through the holes wherever I want it to go, right? Simple enough. We'll just work that out. This is gonna look a mess at the end of the day, but it's fine. We're here to learn, not to make it look perfect. Ooh, so let me just put this through, right? Let's just say I had it set up like this. Just push through. It's not the cleanest. It is what it is. Sometimes I'll just like have it stand up, whatever. But the thing is, when I solder, you don't solder on the top. You don't apply metal on the top side of this circuit. Partially so it looks clean, partially really it's mostly because you don't want, you have 400 degrees Celsius when I turn this on, which I might go ahead and turn it on, start heating it. 400 degrees going to here. If we accidentally touch the resistor with that 400 degrees, we probably fry the resistor. We're wasting our time. Do it to LED, it might pop. There are certain like integrated circuits, certain capacitors, other things like that, where if it gets too hot, then it'll just burn out. And there's ways to avoid it. It was cold. I was just looking at the other day. Heat sinks. So basically, if I had like some clips, some alligator clips, or usually just alligator clips, what I could do is lift this up a bit, like that. Let's say, let me use this clip. This is my helping hands. You can't really see my helping hands too much because my camera's on my helping hands. But you'll see them move in and out because they're gonna hold this when I'm soldering, because I only have two hands. But say for instance, I don't want to burn whatever circuit, whatever component I'm using. You can hold it up, and I will put the clip right here. So let's scoot that in, put it right here. Usually without this like rubber plastic on it. I want it to be metal to metal. So that way when I'm soldering it from the bottom, because that's where I do it from. When you solder from the bottom, the heat is gonna, of course, travel a bit through those wires. It's gonna travel a bit through these wires. And by having this clip in the way, then it's kind of taking some of the heat in the process. Like the heat's not gonna go straight from this wire and go all the way up to this resistor and burn it out. It'll come here and it'll want to travel through the clip more than it will want to travel to the resistor. Therefore, it's less likely to get hot and burn out beforehand. I'm not too concerned with that today. I don't think we're gonna solder anything that's like important. Like I'm not gonna put any integrated circuits or anything on there because yeah, we'll see. But most likely not, just because circuits are they're not as dispensable as resistors. Resistors are like a couple cents each, if even. Circuits vary, so we'll see. And then last but not least, that we'll need before we get started, I'm gonna actually start heating this up. There we go. Let's set this. This one has an adjustable temperature. I used to like repair my jewelry with a soldering iron. So where's that scene? I worked on a project where I was like, I needed to burn a hole into something. And rather than sitting there and poking a hole with it, it's scissors and rotating and trying to like force a hole, I just turned this on. It's like, flop. It's powerful. Like so you can adjust it. I know I've done jewelry type of things with this and just turned it down, but I can like wrap it around to make like cool little circular designs. What else have I used this for? I haven't used it, but I was doing research the other day and discovered that when you solder, like stained glass windows, they're connected by the process of soldering. Like, not all of them. Some of them might use like a heavy industry glue, but a lot of them use like metal to connect them together. And it's basically soldering, just in a bigger device than this. So I'm gonna give this a minute to heat up. Hope it doesn't fall over. It wants to be stubborn, as they always do. What else we got? There's a bunch here. Cool. And then, yeah, so we have these helping hands. These are going to be what we use. So, get them not low enough. This one that I have, I said you can't really see the whole thing because of the angle things are at. But for our purposes, what it is, let me see if I can scoot it over without knocking this guy over. So these are just clips. They're just gonna hold this for us. So like I said, usually we use tape. We're not gonna use tape this time, we're just gonna bend it. But because we're doing it from the bottom, right? We're soldering over here. Obviously, because gravity is a thing, if I hold it like this from the bottom and just like leave it alone, well, I guess it doesn't want to slide out. But if I did like an LED, that's a little less malleable, and I stick it through. So the LED here, right? If I flip it over and just let it go, it's gonna fall out. Physics. What I'll do sometimes is I'll get a piece of tape and like tape the component down on this side so it doesn't fall out. But I don't have any tape, or at least not the tape that I would normally use, because I don't want to use like Scotch tape or duct tape or painter's tape. There's like this, I forget what it's called, but it's like a coppery color. It's really thin, but it's just sticky enough to hold it, but not so sticky to where it's like gonna rip it out. Mind you, I doubt it'll rip it out once you like literally melt metal to make this connection, but you know. So for our purposes, what I'm gonna do is just bend it. Just use my tweezers. So my hands are all in place. So here, I'm just gonna literally bend the sides. And that's just so now it's not gonna fall out, because it can't. So that's gonna be our first step. Then I'm going to alligator clip this. I only need one, but I'm probably gonna use two, so why not? It's not that heavy to where I need two. I need two just to hold things in place. Which is tight. Wait. See if I can get this. I think I can get it too much closer to the camera, but I don't want to. So we're gonna leave it probably about right here. Rotate this just a bit. There we go. All right, so let me see. Sorry, it's not quite hot enough, but it's getting there. So any questions in the meantime? We'll give it like 30 more seconds for it to heat up. And then safety, of course, because that's important. I mentioned on the show before, we were talking about this, that I wanted to make sure we were safe, that I had everything I needed before we proceeded doing this, because soldering is dangerous. Like, you're literally playing with hundreds of degrees of temperature, and hot metal is dangerous. Usually it's not too bad if you know what you're doing, but I just caution to like know what you're doing. Usually I try to have gloves, not always, but sometimes. It's not as, honestly, it's not important because it's important, but it's not as important. Because yes, we're using lead, but the odds of, it's possible to get like solder on you, but in my experience is not as concerning. It's highly unlikely that you're gonna like drip solder all over your hand, partially because you're usually doing it from the top. So the fact of it's like splashing up, I don't really see it happening, but it's possible. I have on my lab coat because I like my lab coat, and also lab safety. And then the more important things, I don't have a fan. You should have a fan. It didn't occur to me till today that I was like, oh, I needed a fan for ventilation. But usually when you solder, you need to have a fan there because, of course, you're melting metal. There will be fumes. So instead, I just have like the fans on in my vicinity to do it. And we're not going to solder too many things, so I'm not too concerned. If I was in like a, there was a lab I used to work in my old school, and the lab was enclosed. Like there were no windows. There weren't really like good ventilation systems. We had some fans, but they weren't always available because other people used them. So I would just wear a mask. But I don't want to wear a mask in my house right now. So we're just gonna vent in other ways. And then of course goggles, which I'm gonna put on in a moment, because I said it's unlike, I already had glasses on, but technically, according to like OSHA safety regulations, regular glasses don't count. And like I said before, I showed you guys, I don't know what they were, except in ability, they all vanished. But there's like little extensions you can put on glasses if you don't like to double up. Because my glasses are circular, they probably wouldn't work anyway. So I'm gonna put these on top just in case of, you know, not getting fumes in my eyes, as well as the really odd event of solder splashing. So yeah, I'm gonna go ahead and do that. Let me get started. I need new safety goggles because these ones are 30. It will make it work. So let's make sure there's no questions in the chat. Okay, itchy. All right. This guy. We're gonna test them out and see. One day I'm gonna just invest in a paperweight to hold this thing down. I actually do have a paperweight, but it's not gonna work for this case. It's too big. Either way, we're just gonna be careful. So the first thing you do is we have our solder. Let's see if I can find the end of it. All right, we have our solder here. The first step is we're gonna tin the ends. What that means, we'll see if it works. Like I said, it's based off the sheet that we currently have. So tinning the ends, or the tip of this, basically means you solder or melt a little bit of the solder onto the end. It helps with just making connections later, as well as keeping the tip preserved and cleaned over time, things like that. So, as I said, hopefully it should be hot enough. So, I'm about to find out if it's hot enough because it'll melt, and if not, then it won't melt. Cool. So I'm sure y'all saw the bad boy is hot. All right, so you probably see the fumes from it. This is just 10 minutes. Cool. So there's definitely plenty. I'm gonna take off the excess over here. Cool. Then we have a little solder on the ends, maybe a little too hot. I have extra water bottle near me just because this bench is gonna dry up. I already picked it up. Cool. I think that's good. So now what you want to do, the important thing with this, so where people mess up with this, just how I was saying, like the heat sink, right? We don't want to have too much heat going through the actual wire itself, because of course it's going to travel to the other side through and burn out that component. Not always. Certain components have different like resistances and whatnot, heat tolerances, but we still don't want to risk it. So the important thing with this is how there's how there's these copper circles around it, you know, right around each of these holes. You really want to put the soldering tip against. I feel like I should have got a thinner tip. I have like interchangeable tips for this depending on what I'm doing, but just whatever. We'll roll with it because it's too hot to change now. So you usually want to hold it against the copper part of the hole, not against the actual wire itself. And then when you get to putting on the solder, you're not putting it against the tip of the soldering iron. You want to hold it kind of like the opposite side of that copper, because that copper should heat up, of course. So if I put it on one side and put this on the other side, it should technically, you know, the heat transfer from the tip through the hole should make it where we it's still hot enough to melt it. And you'll know it's connected because when doing through hole soldering, it'll make like a pyramid shape, like a conical shape around it. So that's how you know you have enough. So that's what we're gonna do. We're just gonna see what happens. So I know it's like hard for me to be seen on camera, but like is what it is. I'm gonna try to rotate a little so I stay a little more in frame, but gotta focus. So I'm gonna do that. So just hold it against it. Half a second. Cool. Maybe the other side. All right. I think that's good. Put that in there. Sit this hold it down, and actually make sure to clean it. And then just make sure to like get any excess off. Like I said, putting it against the wet sponge is going to cool it down. So I just do this every time. I'll put it back. Then when we go back to doing another component, I'll trim it. Keep the chips brush. We'll go from there. Stay still. You don't take over. I know you want to. So take this off. And we're going to inspect and see what this looks like. All right. So let's see if we can get this. We'll adjust and read it. Get it pretty good. I know you want to, camera. There we go. Okay. Well, you can kind of see over here. You can kind of see like the silver fitting in. That hole isn't like completely see-through anymore. That's because the metal's flowing into it. You know, me straightening meat back out these pieces, they're not falling through, you know? So we know that we have a good there. And then if you look at the other side, it's not as filled in as I would want on one of them. It's kind of hard to see into the hole. If I can get it. Oh, okay. So you see on kind of the top one, you kind of see on the top one, you can see some of that solder in there, right? And that's good. Like it's not overflowing, it's not making a mess. It's just like perfectly in there. This other side, not as much. Like it's holding it there. We can see from the other side of it that there is solder there. It is filling in the hole on one side, but it's not quite filled in on the other. What you could do is like put the soldering iron back against that same connection, let it melt in a little bit more, maybe add a little bit more solder. Usually you would test with like a voltmeter, or still haven't gotten a voltmeter. You would test with a voltmeter the connection, make sure it's still reading like the proper resistances, you know, from each side and measure the resistance. And if it's still getting the same resistance, then you have a good enough connection. If not, I'd go back and put a bit more solder in. But since I think this is good enough for this piece. Like I said, even though the top side may be missing a bit of solder or not fully filled in on that hole, might be too close. There we go. So yeah, one side isn't quite filled in from a top view, but because we never want to solder from the top, like I said, you'd have to just go back on the bottom side and melt it back so it flows through a little bit more. For now, we're probably gonna leave that one. I would just have magnifying glasses. I know I'm not checking them, but we're gonna just try a different component. Now that we got this. So this is really the basics of soldering. Looks like this. It takes a lot of practice. A lot of people, as beginners, usually will overflow on solder, which is a bad thing because, say, let me put this back in here. You know, like I was showing before, you go across, on the other side it's not cross, but on the one side of this, it's in sections of 3, right? And then you got the whole row here, whole row here. If you overflow, say I'm putting something in one hole and the solder overflows into the next one, it kind of like activates. It activates the other one. So if I had components next to each other, say I had a solder one side of like a power connector, right, along this vertical side, this horizontal side, and it overflowed into the next row, then that next row across will also now have power. And if I accidentally, you know, like, oh, well, I'm gonna put a resistor there, LED there, not noticing that I overflowed into another row, then I could potentially blow my whole circuit. So you want to be really careful about making sure to not overflow. And if you do, that's when we do the desoldering. So let's see if I can desolder this today. Actually, I'm gonna put another piece on, and I'm probably gonna purposely put too much solder, and I'll show you how to take it off. And so I'm not gonna use the other like suction one because I don't. I've personally really never successfully used it. I just don't like them. It's excessive. So I would rather use my solder wick myself. So I'm gonna go ahead and just put this random LED on. I'm just trying to find parts that like don't too much care about. I'd almost put a wire. So why would I do that? Yeah, we're just going to put this LED on here and then take it back off. I try not to too much desolder things. Hopefully just get it right the first time, because sometimes desoldering, the amount of heat you have to use and hold on to get it off might automatically burn out the piece anyway. So it's like, I might as well just let it, like, hopefully I get it right the first time. If I don't, it's done for. So yeah. All right, let's put this back in the frame. Cool. Let's see if I can rotate it a bit. There we go. So we're doing, rotate the other way. We're doing this one. This LED in the back. I'm gonna go again. Do this. And I'm gonna put way too much on here, so I can show you to take it off. So then clean it a little bit. Tin the end. I'm sure you see all these fumes, which is why, like I said, usually you would have a desk, a lab fan here to collect those fumes, because it is partially 40% lead, which is tough. So yeah, very good. But like I said, I have every window open and fans going in other places, so I'm not too. And I'm not usually like completely over it. Sometimes I'll have. I'll move it for a second so you can see it real quick. Maybe I'll just flip over and burn stuff. Ooh, no, we're not gonna move it. Okay. On my helping hands, there's a built-in magnifier. Like, instead of a clip here, it's just like a big, you know, those like circle lamps that like YouTubers use. It's one of those where like the outer ring is a light. The inner ring though is a magnifier. So I could move it around right now and, you know, put it right here in front of me. I turned everything at different angles. Put it right here in front of me. Like this. It's a circle over it. And then I can see it a lot clearer. But for our purposes, I'm just gonna like kind of stay out of the way. And if I look that close to it, that's when I'd be a bit more concerned about wearing a mask, having that fan in place, because no one wants to breathe in lead. It's not good for you. So go ahead and do this one. All right. So again, you hold it against the copper side, not against the actual wire. It heats up pretty fast. So maybe this one will heat up pretty fast. I did turn it down a little bit. Okay. It dries really fast though too. You put way too much. All right. Here. All right. So I'll bring this in. You can see. Boom. So we got our connection here, but you see the one closer to this finger here. This guy. Everything's backwards. It's like really hard to move this. This guy here. There's extremely too much solder on that. Let's see. I can get it at a different angle. It's a little hard to see. It's want to fully focus. You can kind of tell that over here, it's a little bit overflowing his circle. as well as there's solder like all on the arm. So if I were to cut this where the solder is, where to cut this? Where to cut this? You know, this is 7 bucks for me. Yes. It is. Helping hands are like the best thing ever, and I wish I could have like 8 of them. So this one, we just cut pretty low because it came out pretty decent. This one, not so much. Like there's so much excess solder on here. Catch it, focus, camera. You can do it. I just want to do it now. You're doing so well. There we go. Kind of. Either way, over here. Oh look, there it is. Over on the. Yeah, there we go. Yeah, it's gonna go in and out a bit, but you can kind of see it when it decides to focus. We'll work on that later. I'm just trying to stay still. But you see one side has a lot more solder on it than the other. And that's no bueno. So what we're gonna do is I'm gonna take this off. I'm probably gonna try to take the whole component off if it wants to work with me. So let's go and get the solder wick. Pull up some of that. So how solder wick is used, let's get a bit closer for you guys, is get the wick, you hold it against whatever piece, try to get as close as possible or right on top of it, and you'll just put the tip on top of the wick and it'll suck it up. So yeah, there we go. It's kind of hard to see. I'll kind of show you a little closer as we approach getting all of it off, if all of it even comes off. I'm sure it will though. We're getting a good amount. Just trying to get as much as possible. It's really kind of cleaning it up rather than fully desoldering it. Yeah, so yeah, the principle is that it's like when you spill water, you put a paper towel on top. It's the only reason we're using, of course, like the soldering iron to melt the solder in order for it to want to move with this metal. But it's the same concept. You're holding it against it, and as the solder melts, it's sucking it up and absorbing it. So I will say be careful with these because they get hot. Heat trap, like that's why I kept moving my hand because I could feel the heat going up the wick. But if you look at it now, just on the back side of it, we have this. It's not the most focused, but you can get the gist of it. It has absorbed the solder onto here. So you can just do it throughout the whole solder wick, and then when you're done, you can just like clip it off. Wow. I used to have a bunch of these, but yeah. But it's one way to clean it up. So I'm not taking the component fully off, but let's see if we can get a little better view of this. So you see now how much cleaner it is. There we go. It's so much cleaner. Even in the original ones that's over on the side that's unclipped with the resistor, it's so much cleaner. It's not going outside of the circles really. Yeah, it's within those circles. Even there's enough cleaned up off of this to where I could trim it even more and get it even closer. I'm so proud of myself. Well, that's how you do whole solder. There's on the other side while we're here. Oh, we got a bit excess. All right, Let's see if we can get underneath the LED to see kind of what's under there. Do it. There we go. So you see it's not too much. One side of it is cracked up the leg a little bit. The other side's pretty good. Like you can't really see through it. Like it doesn't really look, you see just enough solder on one side. Like I said, the other side has a bit excess, but it's not overflowing into the other hole. And even the side that has less solder, you can tell that it's grabbing onto that leg just a little bit. It's not like sunken in as to where, you know, over here, where you can see one side has a little space and the other side is like a full connection. So if we were doing this LED, beautifully done. I say so myself. Yeah, so let's see. Any questions right now? We'll probably throw on one more. And my magical sources. My magical sources are telling me from great young that we're doing poll in chat. So exclamation point votes, great or awesome for the show. Is it great or is it awesome? I think I'm awesome. I think my soldering skills are awesome right now, honestly. Like I'm hyping myself up because I've probably been soldering on and off for like, oh my God, I'm doing this. 5 years. Thanks, guys. Thank you. Dangerous Zone for thinking the show is awesome. Or at least this part, not the whole show. Hopefully you think the whole show is awesome. But yes, thank you. It's I've been doing soldering probably on and off for 2 years, 21, 7 years, 6 years, somewhere in there. Not fully consistently, like I said, surface mounting. We'll see. That's all I'm gonna say about that. We'll see. Because I need, the only problem with that is because it's so tiny, like the components themselves are probably smaller than these holes on here. And you have to be able to hold them in place. You can't like bend the parts because they're not going through a hole. You can't push them through a hole and bend them to hold them in place. So you kind of just gotta, it's a whole different thing. It's called tacking, where you just slightly add enough solder to the board beforehand, put the piece on and hold it in place, and then you just kind of like pop. Like a really quick connection type thing. Maybe we'll come do like a second show because there's some other techniques you can use for this, where usually there's surface melt techniques through holes, not as necessary for this. But if I was doing like, let's snap the piece off. I was doing something like this, right? Some headers. And I wanted all of these headers to be connected to this side. They're straight across, right? We'll put that through. This is when I would tape it, because I can't really bend. I mean, I could technically bend this, but I'm not really wanting to. Put it through that way. So in this case, I don't have anything to hold it in place right now. Actually, I'm gonna try this. I don't know if it's gonna work. I have another helping hand. Welcome hand number 3. Let's see if it can hold it in place for me with the other hand. I think it can. I think it can make this work. What I'm gonna do is I'm gonna drag solder, which is I'm gonna heat one side and kind of just move along, just like we'll just like slide it across to get all of them at the same time. It's usually more of a technique for when you're doing surface melts rather than through hole, but we'll see if I can even get it to hold the piece in place, because like I said, it's on the edge and I can't really bend these parts on here because they're so short and they're a little thicker. So let me see if I can get it in place first and foremost. And if not, I'll just put a different component on here. Let me see if I can get it. Any questions, guys? Feel free again to ask questions in the chat, comment. Let me know about other stuff you want to see. Like, do you want to see surface mounting? Because if so, I'll show you. Not today. Because I don't have any surface mount materials, and I have to buy some other type of board in order to do it. Let's see if I can get this back. Decent position. Let me know about that. If you want to see any, let's say we're going to do an Arduino, like a full one from scratch, which requires doing a bunch of this. It's just a bit more intense. Stay. It's close enough. We're not gonna get any more close to that. It's in place. It's just enough. We're gonna work with it. So I'm gonna just blast through this real quickly if I can. We'll heat up the side. Come on, Summer. You can do this. And I have faith in you. That's all the things. So some of them came out better than the others. It happens. Clean this bad boy up. So, put it in there. Wait. So, and what tacking is how I use this piece to hold it. If I were tacking this, usually you would put it in place, you would use something to hold it, like tape or another hand to hold it. You'd solder just one connection, and then you can take the tape off, you can take this off, because at that point you have metal bonded to other metal, it's not going anywhere. This solder cools down in like a fraction of a second, maybe 2 seconds. So are the pins straight? Yes, in this case. So that's why I didn't want to bend them. So say, what's the opposite header? Say I had like a component. Where's those things? Say I had like a female connector. Say I had like a female connector like these. These are male to female connectors. So I could get one. Put this on here, right? And then now, because they're straight, I can just plug it straight in. So this comes in handy. Say I was building a quick small circuit where I was building a circuit where I was like putting one of these on. It's very crucial to make sure that it goes through straight, because then I may need to put something on the other side. Yeah, usually like that. So there's certain things and parts where you don't want to bend them, but you can if you're really putting through a hole. It's not always as crucial to make sure it's straight at the end, but if it's something like this where it's a header, the whole purpose of it is to remain and keep it straight, which is why rather than putting this side through, I knew that this side here was set up for these type of headers. So I wanted to make sure it was straight so I can put these on later. Versus how to put it on the opposite way. Then these pieces back here, you see how short they are? I haven't trimmed them or anything, but they're so short that I couldn't do nothing with them. So usually stuff like that. And each points are different, like, just like when you're doing a breadboard, certain, resistor, doesn't matter which way you put it on. Just what's this? Thermal resistor, I believe. Like this. Photoresistor, they pick up like resistor heat. Yeah, this picks up light. So these, because it's still kind of a resistor, current can go either way. So it doesn't matter which way you put it on, versus an LED where, you know, if I was paying attention to making sure that like we're not crossing lines, it has to go into a certain direction because it has a positive and a negative side. So when it comes to soldering, you just have to pay like a little bit more attention, because when you're breadboarding, you know, like we were doing before over here, when you're doing breadboards. I need a third desk, guys. But you may get because my lab space is getting extensive. So here, when we're doing breadboarding, of course, look at that. We can actually see the board this time for the first time in like 5 weeks. You can just like take components on and off with the simplicity, you know, quickness. But when you're doing soldering, once that piece is on there, that piece is on there. Yeah, you can desolder, but like most likely you're going to overheat the part and just have to replace it. That's extra time and effort that you have to take out in order to take it off and put another piece on. Your circuit's going to look less pretty, which some people don't care about. I care about. Not that it matters. As long as it works, but still. Yeah, so basically, so there's 3 steps in this process, right? There's like a life cycle to circuit design. Let me turn this on. I think we're done soldering. Let me turn this off. So I don't hit it to flip over and burn something. So there's a life cycle to board designs. So we go in 3 steps. This is the order. This is the order, right? You start here. I mean, you don't really start here. You probably would start with a schematic that you did, like we did last week when I showed you how to use E.V.E. You would do something like that where you pulled it up in E.V.E, you designed it there, and then there's ways in E.V.E and other PCB design softwares where you can virtually test it. So it'll know what power is. It'll send power through it, like turn it on, and you can see how it's moving, if it works, stuff like that. Once you do that, then you come here to your breadboard and say, okay, now let me build it and see if it works in real life and not just like in a simulation on a computer. So that's what we did last week, where we built out the schematic and we were like, okay, this is what the schematic should do. I'm going to put it here and test it out. And once I see it works here, I'm like, all right, now let me get this chunk. And I have this big board. I really like these ones because I can break them into pieces, which is why this little one. It was like this, and I just like broke it up. So if you have like a really small circuit that you need to do, I could probably fit this whole thing onto here. Yeah. Maybe I'll test it next week and we'll do that. If I can get, I might have to cut some wires. That's another thing. If we do it next week, I'll show you how to connect wires. Next we have time. We'll see if I have time real quick to show you how to connect 2 wires. Because that's how this robot is. We don't want to get into it on air, but I'll show you in a second. But yeah, so once you get it working on your breadboard, you put it onto this. These are literally called Protoboards. So your breadboard, because I don't know why it's called breadboard. But this is a Protoboard. This is where you prototype. So you'll put everything here once you know it works. You lay it out here, and then you'll test it again. And if you see it works here, then that's when you say, okay, I see the circuit itself should work. You would get that schematic that you designed, and you can convert it into like a virtual version of this. And I showed it a little bit last week where you can like flip it to where it's not just like the lines and connections. It actually will show you a board, and it wants you to move the pieces onto the board. Once you have that, you'll send it off, and you'll get a board back where it's laid out, but the pieces aren't on. They're not going to usually put the crystals, circuits, and the resistors on for you. It'll just give you the layout of where they should be. And then it's up to you after to get it again and solder the surface melt parts on there. And once you do that, then you have a full functioning like this. You probably won't make one of these. Pretty sure we won't. If I can find some just blank PCBs without components on them, then we will do some surface mount perhaps. But in terms of the whole life cycle, design the schematic, get it synced out, ordering them, we might not do that. We'll see. Like I said, it's all a journey. Most likely, like I said, I'll test it out and see if we can get it working. If I can do it on here, on this board, what we can do perhaps is just get this Simon on the breadboard and convert it onto this and see if it works. But I will see. I have to do a test of different circuit first before I move all of these parts. So yes, anything else? And then last but not least, I'm not going to do one right now, so I just literally just turn off the iron, and it's going to take like a couple minutes to heat up. And we're getting a little close to time. Well, over time, a little. So you can solder wires. This isn't the cleanest one I've done. These are two separate wires. I don't remember why I soldered them together, in all honesty. I really don't remember what this was for. But it's why we haven't worked on this robot yet, because I'm like, what is happening with this guy? I don't know. We'll see. I do plan on getting another one. The one I want to get to show you guys next is it will only want to ride for like a couple weeks. So we'll see. We'll probably do something else in the meantime. Different robot kitters and such. But for wiring, it's the same as if you got putting components on the board. The only difference is you'll come over here, you would strip off just a little of this side so that the wire is exposed. Same on, say, this, I mean, obviously you wouldn't connect these two, but for example's sake, you would strip off a little here. Then I would like hold them, right? Hold them in the helping hands, stripped. I would get my soldering iron, get my solder, and I would cover that whole exposed wire with solder on one side. And I do the same, the whole exposed wire, I would cover with solder on the other. Once they both are covered in solder, then I would turn them so that they're overlapped. So where both metal sides are overlapping each other, then I would just come in with like the soldering iron, just like, and then it's done. And it would just meld the solder that's already on there on each of these together. So rather than putting even more, which in this case is why this one looks a bit chunky. You look at it, it's a little chunky because I put excess on there. But if you do it right, then the solder that you already put on each one individually, you can just melt them to kind of like smooth together, and then boom, you're done. So it's not too complex. It comes in handy. Like I said, those are the type of situations where, you know, if you have exposed wiring on like your headphones or your phone charger, I don't know, I can only come up with phone examples because they're the most relevant, I think. It's those cases when people are just like, oh, I'm gonna repair your headphones. 90% of the time is what they're doing is a wire came loose or broke or snapped, and they just expose the wiring, get a little solder, remake the connection, and cover it back up. So now you know how to fix your own headphones at home. Be safe. I recommend wearing a resistance band. Not that if you have headphones, it should be an issue. Make sure they're unplugged. Let me just start. Don't solder things that are powered. I haven't done it. I don't really want to know what would happen if you did that. But when doing anything electronic, make sure you're powered down, like always. If you have any exposed wiring, you will get electrocuted. I've been electrocuted once, probably more than once, but it's not fun. It wasn't when I was doing electronics, but I've been electrocuted. I guarantee you, it is not an enjoyable experience like it might seem if you think that it seems enjoyable. So be safe. Make sure you're powered down. Preferably have a resistance band on your wrist or on your feet to ground you, so that in the event like you do get electrocuted, it doesn't really go through you. It'll go straight to the grounding band. That's the whole other conversation. So yeah, let's see if we have any other questions in chat. Anyone have any questions? Like I said, we're gonna do this every week at the same time. What are we gonna work on? We'll find out each week. But like I said, as we go along in time on the show, I think we've covered a lot of the basics for what we need to do to get the show going. Let me take these off. We've covered a lot of the basics. I'll go through and check and see, just from my notes and my memory, if there's really any other like fundamental things that we need to do. But I'm pretty sure we've covered a lot of the fundamentals we need to get started with a bit more advanced things. So going forward, what we'll probably do, I've got a couple ideas in mind. It's just a matter of resources. You know, like I said, there's one robotic kit that I would love to do on the show, but it's going to take like 3 weeks to get here because it's out of stock everywhere, unfortunately. So that's one thing. There's a robot arm that I want to build, but I need a 3D printer. So when I get the 3D printer, we'll do like how to 3D print things, and then we'll actually build that hand, work with some other sensors, like flex sensors. They're like these long sensors. You'll put like a whole sensor like down your hand, and it'll tell when there's been like flexing motions happening. So that's how we control that hand. What else we're gonna do? I said we might do putting the simple assignment onto this proto board, or we might, well, not might, but we will definitely build our own Arduino. We'll probably do it on this one because it's already more or less laid out in the way of an Arduino. Maybe. So we'll see how that goes. Otherwise, if there's no other questions, then I just want to make sure, well, first off, I want to say thanks for coming and enjoying the show. Make sure to follow us because there will be more stuff next week. Reach out to me on Instagram, which is Electric Empress. I'll put it in chat. There'll be an update next week about that, so keep your eyes open. But you can always reach out to me here, and then you can get more like day-to-day, maybe week-to-week updates about what I'm doing in tech with the show, outside of the show. You can also come every Saturday to make.sc/Twitch to watch the Twitch show. You can watch Brian's show after mine, which is on Tech Topical. You can watch Yusuf's show on Tuesday. There's all sorts of content here, so make sure to like tune in. And let's join the Discord because you hear about like other events that we're having with Make School, outside of Make School. You can see like my cool projects when I make them. And then just kind of let me know like different things that you want to see on the show. If you have looked online and saw like a really cool robot kit, you're like, hey, Lee, you should build that. Then I'm like, cool, so I'm gonna go get it and build it on the show. Or like a new technology that you're like, hey, this new way to solder. Why don't we like test that out? So keep me updated. I'll keep you guys updated. Otherwise, if you have any other questions, thank you again for coming, saying my show is awesome, because I think it is. So we'll bid you all a farewell. I hope to see you all next week. We're gonna do more techie stuff again and just have general fun playing around with like electronics and robotics. So see you all next week. Have a good afternoon.